Dear students, so far in Unit 3, we have discussed permutation and combination. As a next topic in this lecture, we will learn the statement of pigeonhole principle and the generalized statement of the pigeonhole principle, and also the statement of inclusion and exclusion principles. Now let's understand the statement of pigeonhole principle. The pigeonhole principle states that if n pigeons are to be accommodated in m pigeonholes and the number of pigeons is greater than the number of holes, then at least one hole should contain two or more pigeons. Okay. So that is, if the number of pigeons is more than the number of holes, then at least one hole should contain more number of pigeons, that is more than one pigeon. This is formally quoted as if n pigeons are accommodated in m pigeon holes and n greater than m, then at least one pigeon hole will contain two or more pigeons. Now let's take the statement of generalized pigeonhole principle. This further characterizes the minimum number of pigeons in a hole. The statement reads this way: if n pigeons are accommodated in m pigeon holes and n greater than m, that is the number of pigeons is greater than the number of holes, then one of the pigeonhole must contain minimum of n minus 1 by m, the floor function of n minus 1 by m plus 1 pigeons. Let me explain what the floor function means. A floor function of 1.3, that is floor function of x, is the greatest integer less than x. That is, the floor function of 1.5 is 1. The floor function of 1.9 is also 1. Okay. Now let's try to prove this principle. Suppose a contradiction. Let each hole contain the floor function of n minus 1 by m pigeons, at least at the maximum. That is, each hole has maximum of the floor function of n minus 1 by m pigeons. Then we have m holes. So the m holes will contain the maximum of m into floor function of n minus 1 by m pigeons. But we all know the floor function is less than or equal to x. The floor function of x is less than or equal to x. That is, we know the floor function of 1.2 is 1. That is, 1 is less than or equal to 1.2. So m into floor function of n minus 1 by m is always less than or equal to m into n minus 1 by m, that is equal to n minus 1. Therefore, the maximum number of pigeons in m holes is going to be n minus 1. But we have to accommodate n pigeons. So this being a contradiction, which is one short of the total number of pigeons, therefore at least one hole must contain, or at least, that is, one hole should contain at least the floor function of n minus 1 by m plus 1 pigeons. This is the generalized pigeonhole principle. Now let's move on to the principle of inclusion and exclusion. This is the one we have already learned in our set theory. If there are two sets A and B, both finite, that is their cardinal number is finite, also the subsets of the universal set, which is also finite, then n of A union B is equal to n of A plus n of B minus n of A intersection B. In general, if you have n finite subsets of a finite universal set U, then n of a1 union a2 union etc. union an is equal to n of a1 plus n of a2 plus n of a3 plus etc. n of an minus n of a1 intersection a2 minus n of a1 intersection a3 minus etc. n of a1 intersection an minus n of a2 intersection a3 minus n of a2 intersection a4 etc. minus n of a2 intersection an and so on. And the last term is going to be minus 1 the whole power n of a1 intersection a2 intersection an, which can be written in the sigma notation as summation over I n of ai minus summation over I less than j n of ai intersection aj plus summation over I less than j less than k n of ai intersection aj intersection ak so on plus minus 1 power n of a1 intersection a2 intersection etc. an. In the next video, we'll discuss the problems based on these principles. Thank you.